Hi everyone, James again. This is homework 10, problem 1. It's an inductor that has a current going through it that's a function of time. And so you get a voltage across the inductor or an induced EMF. It's the voltage across the inductor or induced EMF that has magnitude equal to the inductance times the magnitude of the time derivative of the current. And so it's really plug and chug. Part A, find the magnitude of the induced EMF at time 1 second. So we just plug in L ddt of t squared minus 7t. And we take the derivative. So derivative of t squared is 2t. And derivative of minus 7t is minus 7. And so we plug in. The inductance is 20 millihenries, so 0.020 henries times 2 times the time, which is 1 second in part A, minus 7, which has units of seconds there. So actually, the units, let me forget about the units here. I'll put in units at the end. So it's 2 minus 7 is minus 5, and I'm taking the absolute value to get the magnitude. So I dropped the absolute value sign. So minus 5 times 0.02, absolute value is 0.1. And units, I'll let you think for a second. If you want to pause it, go ahead. Yeah, units are volts. It's a voltage. So that's part A. Part B, it's again plug and chug, except now the time is 4 seconds. So we take the expression we found, L times absolute value of 2t minus 7, and we plug in L is 0.020 henries times absolute value of 2 times 4 seconds. So 2 times 4 minus, I guess, 4.00. I should, for sig figs, I should put 4.00 minus 7. And then we get, so 8 minus 7 is 1, so it's 0.020, again, volts. And part C, it's saying, at what time is the EMF 0? Well, the expression for the EMF is L times 2t minus 7. If that's going to be 0, divide by L, you're going to get 2t minus 7 equals 0, or t is equal to plus 7 divided by 2 is 3.5. And it's going to be seconds because it's all MKS units. So it was just plug and chug. The one thing that might be troubling is that we didn't write the units for these quantities. So remember the current, let me just show how this works. The current was written as t squared minus 7t. Okay, there are actually units that go with that, right? Because a current is in amps. So if we wanted to be really, if we wanted to show all our units to be really show fine detail, we would write not just t squared, but t squared with units of amps per second squared minus 7t. The 7 would have units of amps per second, right? Or we could just write, it'd be even more complicated the other way. So yeah, if we wanted to show all units, we would write something like this. The reason is the units of the current are amps. T has units of seconds, so second squared has to be canceled by second squared to get amps. And here, T has units of seconds, so seconds have to be canceled by seconds to get amps again. And so just in case you're looking for units, remember that the voltage we're talking about is L magnitude of di dt. So this means that the units volts are equal to the units of henries, di, which is amps, dt, which is seconds. So in the end, you will get volts from Henry amps per second. And so we didn't show the units that went along in the current with these terms. They were meant to be understood. So basically, if you want to follow the units through, just remember that each term in the current is actually amps. So we were leaving some things off to be pithy, right? Okay, just things to watch for as you progress in technical subjects. Sometimes things are implied that aren't obvious to a person just starting out. So anyway, a long digression at the end. Basically, the problem was plug and chug. And there it is. All right. So thanks for your time, and I hope this was of use, and have a nice day.